this video, we introduce satellite concept and discuss how satellites are identified and explained. We summarize the operation of satellites ground station and review typical satellite application, including the Global Positioning System, which is worldwide satellite-based navigational system, and satellite radio and TV system. What is satellite communication? A communication satellite is a microwave repeater station in space that is used for telecommunication, radio, and television signals. Communication satellites are also referred as polar satellites that passes above or nearly above both the poles of the body orbit on each revolution, and hence it has very close inclination of 90 degrees to the body equators. Satellite communication and telecommunication, the use of artificial satellite to provide communication links between various points on Earth. Satellite communication play vital role in the global telecommunication system. A satellite is an artificial object that orbits around a celestial body like the Earth, Moon, or Sun, performing specific tasks. Satellite orbits that the Earth are and receive signal from ground stations, amplify them, and then retransmit them to other ground stations. Communication. Satellite communication is transporting information from one place to another using a communication satellite in orbit around the Earth. A communication satellite is an artificial satellite that transmits the signal via a transponder by creating a channel between the transmitter and the receiver at different Earth locations. A balance between the inertia of the rotating satellite at high speed and the gravitational pull of orbit body keeps the satellites in place. Satellites are launched and orbit for the variety of purpose. The most common application is communication, in which the satellites is used as repeater. How satellites communication work? The communication satellites are similar to the space mirror that help us bounce signal such as radio, internet data, and television from one side of the Earth to another. Three stages are involved which explain the working of satellite communication. These are uplink, transponders, downlink. In satellite telecommunication, a downlink is the link from satellite down to one or more ground station or receiver. An uplink is the link from the ground station up to the satellite. Some companies sell uplink and downlink service to television station, business, and other telecommunication carriers. A transponder is a device that receives and retransmits signal to the different location. Transponders are used in satellite to relay communication signal and are capable of processing, amplifying, and retransmitting a range of frequencies. Let's consider an example of signal from television. In the first stage, the signal from the television broadcast on other side of the Earth is a first beam up to the satellite from the ground station on the Earth. This process is known as uplink. The second stage involves transponders such as radio, receiver, amplifiers, and transmitters. These transponders boost the incoming signal and change its frequency so that the outgoing signal are not altered. Depending on the incoming signal source, the transponders vary. The final stage involves a downlink in which the data is sent to the other end of the receiver on the Earth. It is important to understand that usually there is a one uplink and multiple downlink. Satellite communication service. There are two categories in which satellite communication service can be classified. First, one-way satellite communication. Second, two-way satellite communication. One-way satellite communication. Following is the figure which explains the one-way satellite communication. In one-way satellite communication, the communication usually takes place between either one or multiple Earth stations through the help of a satellite. The communication takes place between the transmitter on the first Earth satellite to the receiver, which is the second Earth satellite. The transmission of the signal is unidirectional. Some common one-way satellite communication is position location service are provided by the radio. Tracking is a part of space operations service. Internet service take place with broadcasting satellites. Two-way satellite communication. Following is the figure for the two-way communication. In two-way satellite communication, the information is exchanged between any two Earth stations. It can be said that there is a point-to-point connectivity. The signal is transmitted from the first Earth station to the second Earth station, such that there are two uplink and two downlink between the Earth station and the satellite. These satellites all have different purpose, and they are all at different orbit. Orbit in this case is the path that satellite follow while revolving around a planet. Let's take a better look at the types of orbit.
Types of satellite orbit: geostationary Earth orbit, low Earth orbit, medium Earth orbit. Geostationary Earth orbit or GEO. These satellites are in orbit 35,768 km above the Earth's surface along the equator. Object geostationary in orbit revolve around the Earth at the same speed as the Earth rotates. So, to view on the ground, a satellite revolving around the Earth in geostationary orbit, a height of 35,786 km would appear fixed in the sky. This is because the angular velocity of the satellite is in sync with that of the Earth. Both the Earth and the satellite covers 360 degrees in 24 hours. Having a satellite fixed in space helps because you do not have to track the satellite. You just point the equipment to the satellite once and you do not have to bother again. Admittedly, getting a satellite to a geostationary orbit is hugely expensive and the equipment is complex, but in applications like television, DTH service, the transmission can be scaled to a lot of people and the reception equipment is cheap. Advantage and disadvantage of GEO. Advantage: a GEO satellite distance from the Earth gives it a large coverage area, almost fourth of the Earth's surface. So if the satellite is far from the Earth, many area can receive signal. Then, GEO satellite have a 24-hour view of particular area. This factor make it ideal satellite broadcast and other manipulation. So, this satellite is most effective for broadcasting. Disadvantage: GEO satellite distance also causes it to have a weak and time delay signal. So, as we recall, 35,786 km away from the Earth. That's why there's time delay. GEO satellite centered above the equator cannot broadcast signal for a polar region. So it's like a Cartesian plane. The x-axis is the equator and the y-axis is a polar region. The polar region cannot receive signal because the satellite is rotating in a x-axis. Low Earth orbit or LEO. LEO satellites are much closer to the Earth than GEO satellite, ranging from 500 to 1,500 km above the surface. LEO satellites don't stay in a fixed position related to a surface and are only visible for 15 to 20 minutes each pass. A network of LEO satellites is necessary for a LEO satellite to be useful. Low Earth orbit is usually a circular orbit at a height of 160 to 2,000 km above the Earth's surface. Due to a low height and a circular orbit, they are able to revolve around the Earth in about 90 minutes. The line of sight such as satellite is about 1,000 km and they are traveling at numerous speed around the world in 90 minutes. So for a station on Earth to have a continuous connectivity, you need numerous low Earth orbit satellites because such a satellite, though are very easy to launch and because are close to the ground, low Earth orbit satellites do not require high signal strength, which is numerous advantage. Low orbit satellite can also form satellite constellation, which is maintaining specific arrangement with respect to other satellite. Advantage and disadvantage of LEO. Advantage: a LEO satellite compared to a GEO satellite gives a better signal strength and less time delay. Then, a LEO satellite's smaller area coverage is less of bandwidth. Disadvantage: LEO satellites have a limited field of view and required a large network of satellites to provide continuous coverage. Medium Earth orbit or MEO. A MEO satellite is in orbit somewhere between 8,000 and 18,000 km above the Earth's surface. MEO satellites are similar to LEO satellite in functionality. Then, medium Earth orbit or MEO is the area of space between low Earth orbit or LEO and geosynchronous orbit. Then, MEO satellites are used in the telecom, government, energy, remote enterprise, and cruise industry. Then MEO satellites are used in a global navigation system such as GPS. So medium Earth orbit satellite is a satellite in orbiting around the Earth somewhere between 2,000 and 35,786 km above the surface. These satellites take quite a bit longer than the one in a low Earth orbit. Fit go ground, the Earth and hence they are visible for longer duration. They make one revolution in about 3 to 12 hours. Also, since they are higher up than LEO and MEO, satellites have a better coverage of the Earth's surface. The disadvantage is the MEO satellite is higher up, which result is a long time for communication and weaker signal. MEO satellites are visible for much longer period than LEO satellite, usually 2 to 8 hours. MEO satellites have a larger coverage area than LEO satellite. Advantage of satellite communication: installment to a circuit are easy. Then, the elasticity of a circuit is excellent. Then, with the help of a satellite communication, every corner of the Earth can be covered. Disadvantage of satellite communication. Initial expenditure is expensive. There are chances of block of the frequency. Then, propagation and interference. Application of a satellite communication. Telephone, television, digital camera, radio broadcasting, amateur radio, internet case, military, disaster management.